Hello, welcome to GCSE Statistics, Unit 1A, Types of Data, Lesson 1, Describing Data. So, learning objectives. By the end of Unit 1A, you should be able to recognize that data can be obtained from primary and secondary sources, recognize the difference between quantitative and qualitative variables, recognize the difference between discrete and continuous data, recognize and use scales of measurement, categorical, rank, ordinal, categorize data through the use of well-defined, precise definitions or class boundaries, understand, use, and define situations for grouped and ungrouped data, understand the meaning of bivariate data and multivariate data, and finally, know the difference between independent and dependent variables. So first, describing data. Raw data. Statistics are a way to answer questions using information. The information first has to be observed or collected, ordered, represented, and then analysed. The information originally collected is called raw data. The raw data collected will depend on the question that you're trying to answer. The question is often called a hypothesis. So key point 1, raw data is either qualitative or quantitative. Qualitative data is non-numerical observations such as colour or species. Quantitative data is numerical observations such as 20, 8.4, or 29 centimetres. Which of these are qualitative data and which are quantitative data? Number of windows, mass, brand of car. So take a minute to think about that and we'll have a look at the answers. So number of windows is quantitative. It's numerical. You count the number of windows. Mass is quantitative. You measure the mass and get a numerical value. Brand of car is qualitative. Quantitative data. So quantitative data is numerical data. Key point 2. Quantitative data can be either discrete or continuous. Discrete data can only take particular values on a continuous numerical scale. But continuous data can take any value on a continuous numerical scale. The length of a piece of string could take any value on this scale. So the length of a piece of string is an example of continuous data. Weight, length, time, temperature, and speed are all examples of continuous data. So take a minute to have a think about what those have in common. So what they have in common is they're all things that you measure. You measure weight, you measure length, you measure time, you measure temperature, and you measure speed. Discrete data. The number of eggs laid by a chicken can only take particular values. So the number of eggs laid by a chicken is an example of discrete data. Number of siblings, number of doors, number of books, and shoe size are all examples of discrete data. So shoe size is an interesting one. Shoe size is discrete because shoes are only available in specific shoe sizes. So if it's the UK shoe size system, for example, shoe sizes 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Or continental shoe sizes 36, 37, 38, 39, 40. UK shoe sizes also come in half sizes, but what the shoe sizes all have in common is that they're specific values. So shoe size can only take specific values on a continuous numerical scale. Whereas if you measure someone's foot, you can measure it in centimeters or millimeters, for example, and the foot length measurement can take any value on the continuous numerical scale. Are these discrete data continuous? Sorry, are these discrete data or continuous data? A, the weight of a dog. B, the number of flowers in a bouquet. C, the time it takes to bake a cake. So have a think about those, decide whether they're discrete or continuous. Giulietta sold raffle tickets at a village fair. The tickets were red, green, blue, and yellow. So which of the words above can be used to describe A, the number of tickets sold, and B, the colour of tickets sold? So you've got discrete, continuous, qualitative, and quantitative to choose from. So if we look at the solutions, the weight of a dog is continuous data. You measure the weight of a dog or the mass of a dog, and it can take any value on a continuous numerical scale, depending on how accurately you want to measure the mass of the dog. The number of flowers in a bouquet is discrete. You count the number of flowers, and they can only take integer values. The time it takes to bake a cake is continuous. So depending on how accurately you want to measure the length of time to bake the cake, the time taken can take any value on the numerical scale. And then for Giulieta's raffle tickets, which of the words can be used to describe the number of tickets sold? That would be discrete. You count the number of tickets sold, and the number of tickets sold has to be an integer value, so it's discrete. The colour of tickets sold is qualitative data. Categorical data. So to make raw data easier to work with and display, the data may be gathered in a particular way. Each piece of categorical data is put into one of a set of non-overlapping categories. It's important that the categories are non-overlapping because each piece of data that's gathered should belong in only one of the categories. So there should be no question which category each piece of data belongs in. So key point 3, categorical data can be sorted into non-overlapping categories. So have a look at a worked example. Jamal collects data on the colour and engine size of cars. Suggest categories for sorting the data. So colour can be sorted into silver, red, blue, or other. You could suggest some colour groups, include other to cover any you have not thought of, or mixed colours such as a red and black car. Or for example, you could have silver, red, blue, mixed colour, or other. So you can choose the categories. Depending on what you're planning to do with the data, you may choose categories slightly differently. Engine size, E, can be sorted into E is less than or equal to 1 litre. 1 litre is less than E, which is less than or equal to 2 litres, or E is greater than 2 litres. So you need to make sure that numerical categories do not overlap. 1 litre can only be included in one category. So notice the use of the inequality signs there. So 1 litre only belongs in the first category, where E is less than or equal to 1 litre. For the second category, E is greater than 1 litre, or less than or equal to 2 litres. So any vehicle with an engine size greater than 1 litre or less than or equal to 2 litres belongs in the middle category. Any vehicle with an engine size greater than 2 litres belongs in the third category. Ordinal data. So ordering raw data can make it easier to use or display. Questions such as number your 3 favourite fruits, 1 for your first choice, and so on, give data in a natural order, with 1 being the most popular. So questions such as, on a scale of 1 to 5, how likely are you to visit this sports centre again, where 1 is very unlikely and 5 is very likely, use a numerical rating scale. So answers can be ordered by their rating score. So key point 4, ordinal data can be written in order or can be given a numerical rating scale. So we'll have a look at some examples. Is each data set categorical or ordinal? A, students' year groups, or B, the league positions of football teams? And which 2 types of categorical data that you could write 2 types of categorical data that you could collect about mobile phones? Which of these could be ordinal data? A, the marks gained in a test by a group of students, or B, the position of dogs in a dog show, or C, the colours of sweets. So take a couple of minutes to think about those 3 questions there. And then we'll have a look at the solutions. Student year groups is categorical data. So you're categorizing students by which year they belong in. League positions of football teams is ordinal data because the league positions rank the football teams from the football team doing the best at the top to the football team that's doing the least well at the bottom, with the others ordered in between. So league position of a football team or football teams is ordinal data. For 2 types of categorical data that you could collect about mobile phones, examples could be colour, price, memory size, camera resolution. You may be able to think of others such as brand, or there might be other features on a mobile phone that you're interested in that you could categorize phones by. So phones that have that feature and phones that don't. So you have quite a few options there. And for the last question about ordinal data, the marks gained in a test by a group of students could be ordinal data because you could rank the students from highest scoring to lowest scoring or lowest scoring to highest scoring, for example. And B, the position of dogs in a dog show could be ordinal data. So the dogs in a dog show could be ranked from winner down to second place, third place, and so on, down to last place. But C, the colours of sweets, that would not be ordinal data. That's just categorical data. Bivariate data. In many statistical investigations, you investigate pairs of variables to find out how they are related or how one variable changes and affects the other variable. Age and price of second-hand cars, for example, distance and ticket price for train journeys are both examples of pairs of variables. So key point 5, bivariate data involves pairs of related data. Multivariate data. For example, multivariate data for plants could be colour, leaf size, and height. So key point 6, multivariate data involves sets of 3 or more related data values. So remember, if you only have 2 sets of data values, we call it bivariate data. But if we have 3 or more sets of values, we call it multivariate data. So here are some examples. Suggest words that could make a pair of bivariate data in each case. So take a couple of minutes to think about those. See what you can come up with. So for A, you could pair height and weight of people, or height and mass of people. For B, you could pair hours of work and salary, or hours of work and wages paid. And for C, age of computer and cost. Yeah, you may have thought of other pairs, but those are probably the most obvious ones there. Independent and dependent variables. You can collect data from experiments. In an experiment, a researcher is interested in how changes in one variable, the explanatory or independent variable, affect another variable, the response or dependent variable. And you also need to try to control any extraneous variables, that is, any variables that you're not specifically interested in, but which could affect the outcome of your experiment. So as we get further into the course, we'll look at independent and dependent variables in more detail, but at this stage, just need to be aware of them. Right, so we've come to the end of the PowerPoint for Lesson 1 from Unit 1A on describing data. So having watched the lesson, it's time to have a look at the exercise that accompanies it. So we'll just have a look at that now. We may have a look at it if I can find it. Apologies for the delay there. Here we go. So the exercise that accompanies lesson 1 will be available for you to download and work through. So we'll just have a quick look at this because it's the first one. So really, the purpose of the lesson exercises following each lesson is so that you can check for yourself that you've understood the content of the lesson, and you can apply what you've learnt in the lesson. So I have a slight edit to do on the material there. Got an extra letter in there. So as you work through the exercise, you'll find there are 14 questions in this one, and collectively they're designed to make sure that you've understood and can use the information from the lesson. So having watched the lesson, go ahead and complete the exercise, and I will see you in lesson 2. Thank you very much. See you next time.